Hello, welcome back once again. Thank you for joining this channel. Thank you for joining this channel and watching the videos. We hope you get your grade 1 after the end of this series of questions. Okay, so we are here once again to continue our question. The last time we met, we solved question 1 and 2. So today we are going to continue with the question. Now, in our last meeting, we said something very, very important that I need to stress on. That in order to make our grade 1 in math, there are certain things we are supposed to put in place. One being that we need to understand the question given to us first of all. After understanding the question, the way we present our work is very, very important. Then our accuracy, our negative and positive must be on point. Then we might know all these, but if we don't work within time, we will not be able to also complete our questions. Because on the standard examination, you are going to solve 4 questions out of what? Out of 6. So without wasting much time, let's get into question 3. Now, those who have not downloaded the question, you get to the website, which is www.mactclass.com. Navigate to the GHS, look for GHS 3 Math, and the question will be there. You download the question and follow us here on YouTube. Tell your friends to subscribe because there's more interesting things to come. Let's start today's lesson with question number 3. Now, question 3 here says evaluate. So we have evaluate 2 to the power 7 times 3 to the power 4 times 5 to the power 3 all over 2 to the power 3 times 3 to the power 2 times 5 to the power 2. We have to evaluate this, leaving our answer in standard form. Now, this you see here is under indices or powers of numbers. But I like the ending of the question. We say we should leave our answer in what? In standard form. Now, before we solve these questions, let's try and look at those two things. I mean, the indices and the what? And the standard form. Now, when we say indices, per the question, I'll tackle the 2 laws of indices. There are 3 laws, I'll tackle 2 for understanding's sake. Now, under indices, this is the law. The first law says that, and when it comes to this, the law is very important. The law is very, very important. So I'll show you some tricks under this. Now, the first law says that if I have a to the power m multiplying a to the power n, now this is what is happening. You can see that this guy, which is called the base, and this is the base. So once the bases are the same and they are multiplying, all you do is to do what? Is to add the exponents. Are we there? I'm saying that in indices, the first law says that if I have a to the power n times a to the power n, then to solve this, since the bases are the same, so you look at the bases, are the bases the same? If the bases are the same, then you maintain one of the bases and add the exponent or the power. So this gives me m plus n. This is the first law when they are multiplying. But if the second law says that if I have a to the power m times, second law is divided by a to the power n. If they are dividing, then here, since the bases are same once again, then we are going to maintain one of them and subtract the exponent. We subtract the exponent. But you can bear with me that this can also be written as a to the power m divided by a to the power n. With this, when I have something of this sort, I'm also going to apply indices to solve this. And this gives me the same thing as this, because division can be written as this form, and I also get this. We are going to apply this property here. So get ready as with that application. So these are the first 2 laws of what? Of indices that we are going to apply to solve this question. But we were also told to write our answer in standard form. In standard form. Now, when we say standard form, it's a state, it's a form of writing numbers. So that numbers that look very huge can be written so that they look small and more significant. And numbers that are very small can also look significant. That's the reason why we introduce standard form. And every standard form is of the form a times 10 to the power n. This is how standard form is written. So in any standard form, this is how I write it. Now, this one thing you should note about this. Now, this a is a number in this range. A number in this range. A is a number in this range. When the number goes above this or beyond that, we don't take it. That is, if I have A and we have let's say I said A should be what? Should be greater than or equal to 1, but A should be less than what? 10. From algebraic expression, we can list down the numbers here. That means here A can be 1, A can be 2, A can be 3, A can be 4, A can be 5, A can be 6, A can be 7, it can be 8, it can be 9, but A cannot be 10. A cannot be 10 because it's less than 10, but here it is greater than or equal to 1. So A can be any of these numbers. The moment you have A to be a double number, either 10 or 0.5, you have gone within this range. Hence, we have to make sure that our point is always between the first two significant figures. Very important. We always have to make sure the point is between the first two significant figures. So if I have this, then I'm going to move my point so that it will be between the first two significant figures. If I have this, I'm going to move my point. Now, the number of times you move your point determines your n. So n is what? The number of times, the number of times the point is moved. The number of times you move the point tells your n. And the direction you go determines whether n will be positive or negative. These are the things you need to know. So when we get to the final answer, you can write it once again, standard form. I said number should look like this. A should be within this range. When A goes beyond that, if you have 32 cannot be in standard form. So in 32, one thing you should know, that there's a point here because we are working with the decimal number system. So there's a point here. 32 cannot exist here. So if I want to write this as a standard form, then this will move once here. And when it moves once, then it will be between the first two significant figures. If I have 3, 2, 1, 4, and I want to write this in standard form, I'm going to move my point to be between the first two significant figures. So I have 1, 2, 3. So the point is moves how many times? 3 times. The number of times the point moves gives you your n. And the direction in which you go is very important. Now, n becomes positive when you go to the left side, and n becomes negative when you go to the right side. So if I move through in this example, which is 3, 2, 1, 4, 3, 2, 1, 4. When I move my point, I have 1, 2, 3. That means this gives me 3.2 times 10 to the power. How many times did I move? I moved 3 times. But what direction did I go? It also affects the n. I was moving to my left, hence n is is positive, so I maintain that way. If I have 0.05, and I want to write, this is also not a standard form because it is out of the range given. The less than or equal to 1, you can't go beyond that. So we count this so that our point will be between the first two significant figures. 0 in front of a number is insignificant. 0 is only significant when it's after a number or in between numbers. Then 0 becomes significant. So I'll move this. Well, let me write that. Let me say that again and put an example. 0 becomes significant when it is after a number. So a number like 10 is 0 is significant here. Or 101. So when 0 is here, it's significant. When 0 is in between numbers, it's also significant. Good. So we move this guy 1, 2. That means the point is not here. So I'll have 5.0 times 10 to the power. I move how many times? 2 times 2. But what direction did I move? I'm moving up in the negative or into my right. Hence, I get negative. So this is how it's going to be. So we say that let's write this to the right. Just let's put this one down. To the right, n is what? Once we go to the right, n becomes what? Negative. To the right, n becomes negative. N2, so this is a point you have to note for n. Then to the left, n is what? It's positive. So we have to note this. Now with these understandings, then we can go on to solve the question. So we are going to apply this law, and I can see from here, or you can see from here that this is dividing. Hence, we are going to apply this law to solve that question. Then after that, we leave our answer in what? In standard form, applying this. So let's see how this one will work for this. So in doing this, I can start this one by saying, okay, this is my solution. I have 2, 7 minus 3 because they're the same basis, then times 3, 4 minus 2 of the same base, 3, 3, then times 5, 3 minus 2. I'm applying this law here because of the division sign. So this gives me 2 to the power 4 times 3 to the power 2 times 5 to the power 1. This is what I have here. So now multiply. What is 2 to the power 4? Now 2 to the power 4, most of you confuse yourself multiplying 2 with what? With 4. No. 2 to the power 4 means we are multiplying 2 4 times. That is 2 times 2 times 2 times 2. This is 2 to the power 4. So let's go. 2 to the power 4. 2 times 2 gives me what? 2 2 is 4. Then 4 2 is 4 times 2 times 2. Let me go gradually. 4 2 gives me what? 8 times 2. 8 2 gives me what? 16. So now I have 16 here times 3 squared is not 6. 3 squared is not 3 times 2. It is 3 times 3. And that gives me what? 9. So this gives me 9 by any number to the power 1 is the same number. So I have 5. I have 5. So we have this. Now we have to multiply this. Now to multiply this, I'll have 16 times, what is 9 by 5? 9 5 is what? 45. So I have 45. Now multiply 45 by 16. Let me do that calculation here. 45, so I have 16 by 45. Help me do this. Let's go. 5 by 6 gives me what? 30. So 0, 30, 0, remember what? My 3. 5, 1, 5. Plus 3 gives me what? 8. So I have that. 4, 6 is what? 24. So I put 4 down. Remainder 2. 4, 1, 4. Plus the 2 gives us what? 6. So we have this. Then we multiply. We add up. This. We get 0. This and this will give us what? 12. So we put 2 down. Remainder 1. We add 1 to this and we get what? We get 7. So we have 720. We have 720. That means when we multiply this, we'll get 720. But our answer is to be in what? In standard form. So that's what I explained here. In standard form, we have the point here. So we are going to move the point how many times? 2 times, so that it will be between the first 2 signal figures. So I move the point 1, 2. And when I move the point, I have it here as well as 7.20 times 10 to the power. I move 2 times. But what direction am I going? I'm going to what direction? The left direction. And we say to the left, the power is what? It's positive. Positive. Hence, my answer becomes this. Are we okay? Are we okay? Are we okay? Are we okay? Okay. So that is our answer for the question A. I hope you are writing it. Let's go to question B. Question B. So this is question 3A. Let's go to question B. Okay, so now we're going to question 3B. Question 3B. Now it reads, Kwame rode a bicycle for a distance of X kilometers and walked for another half hour at a rate of 6 kilometers per hour. If Kwame covered a distance of 10 kilometers, find the distance X he covered by the bicycle. This is very important. This is a very important question. Now, in this kind of question, I always advise students, anytime you have this in an exam and you are supposed to solve this, always, first of all, read the question to the end, get understanding, then read to a point and try to interpret what you have read. To every full stop or every comma, try and interpret it. This is the best way by which you can solve such questions. Because I know most of you run away from such questions. But the only way you can solve it, or the best way you can solve this, is to take it gradually. At every full stop or every comma, or every breather you say, you write down an information down. By the time you realize you have solved this question, so let's go. Kwame rode a bicycle for a distance of X kilometers. I can decide to say, okay, distance on bicycle. I can say distance on bicycle equals X kilometers. I'll put this information down. Once you get the data from the question, it helps you to solve the question. So always remember, I'll do more of this and tell you more. And what for another, this is what I wanted to take note of, half hour at a rate of 6 kilometers per hour. So that will be the distance. We look at distance for walking. Distance for walking. And this we have to be very careful when we're writing this. Let's go again. And what for another half hour at a rate of 6 kilometers per hour. If we say a rate of 6 kilometers per hour, what that means, if we say 6 kilometers per hour, what that means is that for every 1 hour, for every 1 hour, Kwame walked for what? For 6 kilometers. That's the meaning of this. 6 kilometers per hour means for every hour, for every 1 hour, Kwame walked 6 kilometers. But in this we are told that Kwame walked for half an hour at a rate of what? 6 kilometers. At a rate of 6 kilometers. So half an hour means that what distance is half of the 6 kilometers. It's just what half of 1 hour. So we have this times what? 6. And how do I get the times? Half an hour at a rate of off from board mass is what? It's multiplication. So half of the 6 kilometers, that's what he wants. So if the guy walked half of the 6 kilometers, then what was his distance then? Very simple. So listen to the question very well and read well. Because I also say that most of these answers are in the question. If the question tells me that half an hour at a rate of means what? Multiplication. So half of 6 kilometers will give me what? 3 kilometers. That means Kwame walked for 3 kilometers and rode the bicycle for X kilometers. Let's continue. And the question says, if Kwame covered a total distance of 10 kilometers, total distance covered. So Kwame's total distance equals 10 kilometers. That is Kwame's total distance. Fine. So these are the informations we have here. These are the information. Now find the distance X covered by bicycle. Very easy. Total distance will equal to what? The distance on bicycle and the distance for what? For walking. When I add these two and I equate, I'll get this. Then I get my X. Very simple. Very, very simple. But if you understand that, okay, at every point I'll try and interpret. Now, if you are not willing to do this, there's no way you are going to pass this exam. The only way you can pass is one. You, the students, have to get the edge to sit and go through all this, to listen well and to practice this. That's the only way. If you don't have that edge, no matter what we say, you're not going to get it. So it's first of all start with your willingness to do the learning or to pass this paper, and you are going to make it. So let's go. Now I want to find a distance, but we know that the total distance traveled or total distance equals the distance on the bicycle plus the distance walked. Let's put it this way. My distance walked. So what is the total distance? We have total distance with 10. Then distance on bicycle, what we're looking for, so X. Then plus the distance walked was half of 6 kilometers. So we have what? We have 3. With this, it becomes so easy. Very, very easy. We break this question down very, very quickly. So this gives me, let this one cross. I have 10 minus X. 10 minus 3 equals X. So I get 7 kilometers equals what? X. This is very, very important. The unit, very, very important. When you leave these out, everything is wrong. You might get some of the methods correct, but your final answer without the unit is very wrong. And you'll be deducted some marks. So therefore, say find the distance X covered by a bicycle. Therefore, the distance covered by cycle or bicycle is 7 kilometers. Very simple. I'm done with that question as well. Now let's go to question C. Question C, favorite question. Question C. Question C, my favorite question. Question C. Let's go. Once again, when we have questions like this, when you read down the question, or when you can read the question, write down the parameters. Very, very important. It helps you to know what you have. Once I know what I have, then what am I looking for? And I'm able to get with that. But if I don't know what I have, if you don't write those things down, it makes the work very difficult. Don't be scared of such questions. Don't be scared. Just read the question and write down the parameters. This is that, that is that, that is that. So I have this. What don't I have? Then that is what the question asks you to do. Then you solve that for them. So let's see how we are going to apply that to this question. We are solving question 3C. Question 3C. Now, question 3C. Question 3C. Let's go. A rectangular tank of length 22 cm. So length of tank equals 22 cm per question. 22 cm. Width. So width of tank equals 9 cm, and the height equals 16 cm. 16 cm. So this is the information I have. A rectangular tank of length 22 cm, width 9 cm, and height 16 cm is filled with water. Good. So, like I said, after writing down the parameters, let's see if we can give a sketch for this. So I have this. Don't mind my drawing, it's not drawn to scale. But let's manage it for understanding sake. So I have this. Good. Now, per the question, the length of the tank is what? 22. So I put 22 cm here. Then the width of the tank is 9 cm. So I put 9 cm here. Then the height of the tank is 16 cm. So I put 16 cm here. So this is a diagram. Now, I said this tank is filled with what? Water. Question says that the tank is filled with what? With water. So meaning that we should find the volume. What is the volume of water in the tank? Now, volume of tank, because the tank is a rectangular object. Now, in fact, to find volume is most of the time the base area of a solid figure times its what? Height. Keep that. Volume, most of the time, generally, volume equals what? Volume equals base area, the base area times the height. That means if you give me a cylinder, to find the area or the volume of a cylinder, I'll need its base area times the what? The height. Now this area here is a circle. So therefore, the area of a circle is what? Pi r squared. And I have the height. That means the volume of a cylinder is what? Is pi r squared h. This gives me volume of a cylinder. The base area, which is that, times the what? The height. So I'm going to apply that same thing here. If I look at this rectangular box, the base area is a what? It's a rectangle. And I have the height. So the volume becomes the base area, which is the base times the height. The base times height times the base times the what? The base times the... No, let me go this way. Let's correct this. Let me go this way. So the base area, so once again, one more time will give me what? The base area times height. Now, what's my base area? It's a rectangle. So what's the area of a rectangle? Good. So area of a rectangle equals what? Equals the length times the what? The breadth. That's the base area. So this base area will go for these guys. Then times our height, which is this. Now, per the question, what do we have? We are told that the area is what? So our volume becomes 22 times 9 by 16. No, note that multiplication is commutative. So if you change the position of the values, it's the same. You are not mandated to write length that no, you can take, but answer becomes same. So let's multiply this and see. So I multiply 22 by 16. I multiply 22 by 9. When I multiply 22 by 16, what do I have? Let's go. 2 6 is what? 12. So I put 2, remainder 1. 6 2 is under what? 12. Plus that gives me what? 13. So I have 1 3. 2 1 2. Another 2 1 is what? 2. Then I do my addition, and this gives me what? This gives me 2 5 3. So with this 2 5 3, I multiply with what? 9. So times 9. 9 times 2 gives me what? 18. So I write 8, remainder 1. 9 5 is 45. 45 plus the 1 is what? 46. So I write 6. 9 3 is 27. 27 plus 4 gives me 31. So I have this. So my final answer, which is my volume, now becomes what? 13168. But the unit is very important. Centimeters cube. Why cube? Because we multiply 3 sides. 1 2 3. So cm by cm by cm, according to algebraic expression, gives me what? Cm cube. The cube is very, very important. Therefore, we can say the volume of the tank, which is Ci, the volume of the tank. Therefore, volume of the tank equals 3,168 centimeters cube. So this becomes what? Our volume. This becomes the volume for the I part. Now, II. The water is poured into a cylindrical container of radius. I like this. Now, we pour this water in the container, and this is a rectangular tank, into a cylinder of radius 6 cm. Into a cylinder of radius 6 cm. Let's try and sketch this. Into a cylinder of radius 6 cm. And we are told to find the depth of water in the cylindrical container. So I have a cylindrical container here. And my radius is what? I was told the radius of this container is 6 cm. Then I pour the water from this into this. So the water is somewhere here. So this will be the depth of water in the cylinder. So remember that once I pour this here, the volume here is the same as the volume I have here of water here now. Good. So let's go. Now, so once we pour the water into this, the volume of water here is now 3,168 cm squared. Cm cube, not square. Good. Now let's find the depth of water in the cylindrical container, the depth of water. So that becomes this, which is the height here right now we are looking for. So we are looking for the height of the water. Now, how do we find the volume of this cylinder? Let's call this depth D. And I said to find the volume of something is the base area times the what? The height. But here I'm looking at volume of the water. We don't want the volume of the cylinder, but we want the volume of water. So let's call this D our what? Our height. So let height be equal to what? D. So therefore, the volume of the water in the cylinder volume of water in the cylinder equals, how do you find volume of a cylinder? I just explained that is the base area, which is a circle, so pi r squared times the what? The height. And here we are using d as our height because that's the depth of water. So times what? Times d. So we have this. Now, the volume of water in the cylinder is the same as the volume of water in the rectangular tank because it was poured here. That means we'll have 3168 equals pi r squared times the depth of the water, which is d. I hope you're getting this. I hope you're getting this. Okay, let's go. Let's go. Let's go. Let's go. Let's go into this. Let's go into this. Let's go into this. Let's go into this. So now we're told to take pi to the 22 as 7. So let's do our substitution. We have the radians, we have pi, so we'll do our substitution to get what? The depth of water. So let's go. We have 3168. 3168 equals, this gives me 22 over 7. 22 over 7 times radius, which is 6. So I like to write it 6 times 6. Then times the depth of the water, d, that we are representing. Let the height be what? Be d. Good. So now let's work this thing out. Let's 7 multiply here. So I'll get 3168 times 7 equals 22 times 6 times 6 times d. Now these guys are multiplying here. So when they cross, they can divide there. So I don't want you to multiply this with it. When you multiply 7 with this, you get a very huge number. Cancelling that becomes difficult for you at times. So just let this one be. And let these guys cross one after the other. Or you can let all of them cross to this side. If all these guys cross, or you let them cross one after the other, since they are all multiplying here, when they cross, they are all going to divide. So this will give us 3168 by 7. Don't multiply this weight and come and what and divide this with what? With 22 times 6 times 6. And this equals what? Equals the depth of the water. So we are here to cancel this. Now let's try this. Now 22 will go into itself one time and go here 144 times. 22 goes there 144 times. So now I have 144 times 7 all over 6 by 6 equals d. So I have this. Now the question is, how many times will 6 go into 144? 6 will cancel itself once and go here 24 times. 24 times. So when we have this, let's go. Now I have 24 times 7 over 6 equals what? Equals d. Now, let's go. How many times will 6 cancel 24? 6 will go into itself 1 and go into 24 4 times. So finally we have 4 times 7 equals what? D. 4 times 7 equals d. Now let's multiply this and see. 4 7 gives us what? It gives us 28. Good. So 4 7 is 20. Therefore we have 28. And we are looking for the depth, which is also the height. So 28 cm equals what? D. So this becomes the depth of what? Of water in the cylindrical container. This becomes the depth of water in the cylindrical container. So take note of this question. We'll be going more into such questions. I'm going to explain into details into this question. As we see subsequent ones, we are going to look more into them. So take note. Always read the question to a point. Try and interpret what you have read. It gives you what you have so that you can do whatever the question is requesting of you. This is how we end this section of our lesson. Make sure